mole map out, and I want you looking at it as you do it. 13B has 0.230 grams of PB as a starting point. Now, looking at the three pictures from your mole map, we have a scale, we have a bag of moles, and then we have a spilt bag of particles. If you had to pick one of those three pictures to represent 0.30 grams of lead, which picture would you choose? The scale, the bag of moles, or the spilt bag of particles? What do you think? Why scale? Yeah, because scales measure grams. So it definitely would go where the scale is. So what we're going to do is we're going to kind of mentally replace the scale with this value right here. Now, to get from the scale to the bag of moles, which arrow are we going to use? Top or bottom? The top arrow, because it's the arrow from the scale to the bag of moles. So what we're going to do is we're going to put a little time sign. We're going to put a division line just like you see on the arrow, and then we're going to copy above and below that division line what's on that arrow, which is 1 mole on top, and we have number of grams down below. Now in our case, it happens to be grams of lead. Where do I find those? Periodic table, that's right. So go to the bottom of P block and locate the element lead, Pb. Its molar mass is 207.20. Don't make me do all the work up here. Seriously, get out a periodic table. Okay? It does you no good if I'm the only one doing this problem. So everybody should be doing this with me so you get experience. Okay, so now we've copied what's above and below the line, and that puts us at the position of that bag of moles on the diagram. If I ended this problem with an equal sign right here, hopefully you can see I would be at moles, okay, because that's the only unit I have left. But that's not what this direction said for this problem. It said that it wants you to calculate number of atoms. So which of the pictures represents number of atoms? The spilled bag. And to get to the spilled bag, we have to use the top arrow. So we're going to put another line, another multiplication sign, another division line, and we simply write what's above and below the line just as we see it. So we got 6.02 times 10 to the 23rd particles, which in this case for us is atoms. That's the type of particle we're dealing with. And then we have 1 mole on the bottom. Now at this point here, we can cross-cancel moles as well, found above and below the line, because they'll cancel out. And we are left with a single problem that's going to get us our answer. Okay? How do you solve this thing? You just take all of your top values, you multiply them together. 0.230 times 1 times Avogadro's number. All right, do that right now. Remember to put Avogadro's number in parentheses. So we got 0.230 times parentheses Avogadro's number. Now, you're not done yet at this point, okay? Because I've just calculated what's on top of those division lines. I still need to divide this value here, my answer, divided by 207.20. Okay, I'm not going to multiply that times 1 because I know 207.20 times 1 is 207.20. All right, so hit enter, and what I get for an answer here is 6.68 times 10 to the 20th power. Now, the only unit left over that we see here is atoms, and that's exactly what the instructions told us to find. The element is lead, Pb. Okay, so after this, you can circle it. I did my sig figs on the fly. I noted there was 3 sig figs in this initial value, so I followed suit by putting 3 in my answer. Okay, now what happens if you're asked for something else? Because this is what we did on the lab, this seems familiar. But if you go down to number 14, that's asking you for a little bit something different. Let's look at 14a for a second. The instructions say, what is the mass in grams of each of the following? And then it gives us a number of particles. So this one here starts out with 6.02 times 10 to the 24th atoms of bismuth. Why did they make that number look so much like Avogadro's number? I don't know. Just to make sure that, that you're able to organize your problem.